The next thing we want to do is we want to find the Laplace transform of the unit step function UCT, right? That's what you denote by. So we want to find the Laplace transform of that. So the formula is the Laplace transform of UCT is e to the negative CS over S, where S is greater than 0. You can see how it is that, okay? What is the formula for UCT? UCT is defined as 0 for t is less than c and 1 for t is greater than c, right? So here, so what you can do is basically you can break this integral into two integrals, right? You can do 0 to c and then plus c to infinity, right? And then both of them has uc and then e to the negative s, uct times e to the negative sct, uct times e to the negative sct. On this one it will be 0, right? Because of the definition for t is less than c, this integral will go to 0. So what is left is the only this will be left, right? Yeah, so it will be uct and then e to the negative st dt. That's what you get, right? That's what you get. So 0 to infinity uct e to the negative st dt is limit beta tends to infinity. I wrote just c to beta. Just c to beta. I ignore the 0 to c part because it goes to 0. And what is the value of uct in this interval is 1, right? That's what we got. For t greater than c, it is 1 times e to the negative st dt. Okay. Now, what is the integral of that? It is e to the negative st over negative s, right? With respect to t. Now, this limit is the same. Now, you plug in the limits, upper limit and lower limit next, right? So you plug in the upper limit and then do minus, plug in the lower limit. When beta tends to infinity, this has negative exponent, right? So this goes to 0, so what is left is just that one. So negative times negative will be positive, so e to the negative cs over s, where s is greater than 0. So this is the case for the unit step function, this function, right? But if you, how do you find out the Laplace transform of a function that you turn on after a certain time and turn off? How do you find out the unit step function of this? How do you find out the Laplace transform of this function, UCD? So exactly the same way, what you do is Laplace transform of UCDT equals to e to the negative cs over s minus e to the negative ds over s. How do I do that? You can find out Laplace transform of UCT minus UDT, right? And then what is the Laplace transform of UCT? Just that is e to the negative cs over s minus e to the negative ds over s. That's what you get, okay? So this is the formula for the Laplace transform of UCDT. Now, there is a note: if a function ft is shifted right by c units, then we write it as f of t minus c, right? Do you remember that UCT is also shifted right? U0t was shifted right by, because what was U0t? U0t was from 0 and right, it is 1, right? And from in the left side, it is 0, right? That's what we had. That's what we had, right? That is U0t. So UCT was, it was shifted t units right, c units right, right? So it was like this. That is UCT, right? 0 on the left of c, on the right it is 1. So similarly, if there is a function, some function there, f of t, and if you shift that to the right side, then it will become f of t minus c, right? C unit right, f of t minus c. But if you want to define a function that is 0 on the left of c, this is c, right? 0 on the left of c, and on the right side it is shifted, this original function ft is shifted, then you can denote that function as uct times f of t minus c, okay? So what it says is this UCT provides 0 on the left side and 1 on the right side. So multiply with f of t minus c. That is f of t minus c. That only is the f of t minus c. But if you want to include that 0 on the left side, you need to multiply by UCT. That's what it is saying. Okay. Now the next thing we want to do is we want to find out the formula for this time shifted function. Okay. So if there is a Laplace transform of, if you want to find the Laplace transform of UCT times f of t minus c, this is times f of t minus c, then the answer, the formula is e to the negative cs times Laplace transform of ft. Make sure that the translation on u and f be the same, right? Because here the translation on u is c, the translation on f on c. If they have the same translation, then the Laplace transform of uct times f of t minus c is e to the negative cs times Laplace transform of the ft. So we will see some examples on this, okay guys? Okay, on this example, what it says is we have this formula, we just proved that formula, right? So if you have uct times f of t minus c, then the Laplace transform of that is e to the negative cs times Laplace transform of ft, right? Suppose ft is t, then find Laplace transform of u2t ft minus 2. So how do we do that? So Laplace transform of this is the formula e to the negative 2s and then Laplace transform of ft, right? What is ft? Ft is t. So it will be Laplace transform of t. Laplace transform of t is 1 over s square, right? So e to the negative 2s over s square. So this is how we find out the Laplace transform of this. Now, to find out the Laplace transform of a piecewise function, I think I discussed this already. You need to write in terms of the unit function first and then you take the Laplace transform. For example, find the Laplace transform of this function. So this is a piecewise function, right? So it is 5 between 0 and 2, t minus pi between 2 and 4, and e to the t for greater or equals to 4. So how do I do this? Is so ft equals to, write down in terms of the unit step function, right? So it will be 5 times u02 and t minus pi times 2 u24 and then e to the t times u4, right? So now how do you write that? It is 5 u0 minus u2 t minus pi u2 minus u4, right? And then e to the t u4, right? That's what you do. Now what I'm doing here is by the way, this should be minus, you're right, you see that? Okay, now 5 u0 is just 1, right? So 5 plus t minus pi minus 5, because you see that there is u2, there is another u2, right? You see that there are two u2s, so I'm combining those two. So t minus pi minus 5 u2t, and then how many u4 are there? 1, 2. So you combine those two, so negative t minus 4, so minus, and then t minus pi minus e to the t u4, right? So this is in terms of the unit step function. But there is a very important thing there. What it says, you know that to use this formula you need c here. If c is there, you need t minus c. That's what you need, f of t minus c, right? So since there is, if you want to find out the Laplace transform of this function or this term and Laplace transform of this term, what you need is, since there is 2 u2, so this should be f of t minus 2, right? And since there is 4, this should be f of t minus 4. So this quantity must be f of t minus 2 and this quantity must be f of t minus 4, right? So but to use the Laplace transform, we need the form of uct times f of t minus c. So we write f of t equals to, I'm writing this as 5 plus f of t minus 2, because to find out the Laplace transform of that term, that's what I'm going to do, okay? F of t minus 2 u2t minus f of t minus 4 u4t, okay? You can use another way of doing that, right? Because we know the Laplace transform of u2t. How do you find out the Laplace transform of uct? You can use that method, but we are doing the same problem, slightly different method, okay? So here, so what I did is, since there is u2t, I need f, this function must be f of t minus 2. This function must be f of t minus 4. That's how I wrote it. But what is the value of f of t minus 2? F of t minus 2 is that thing, t minus pi minus 5. And f of t minus 4 is t minus pi minus e to the t, right? Now, so what is ft then? From here you find out ft, from here you will find out ft as well. So what is ft? To find out ft, you need to replace t by t plus 2, right? T by t plus 2. Here, to find out ft, you need to replace t by t plus 4. If you do that, then what do you get? Replace t by t plus 4, t plus 2. T plus 2 minus pi minus 3, but plus 2 minus 3. T plus 2 minus pi minus 5, right? So what do you get? Is t minus pi, and then plus 2 minus 5 is negative 3. So this is the value of ft for this case, okay? And for the other case, what is that? If you replace t by t plus 4, it will be t plus 4 minus pi minus e to the t plus 4, right? So what do you get? It is t plus 4 minus pi minus e to the t plus 4. That's what you get for ft for the second one. Okay. Now we're going to find out the Laplace transform. So you take the Laplace transform on both sides. What do you get? The Laplace transform of 5 is 5 over s plus. What is the Laplace transform of f of t minus 2 times u2t? The formula is e to the negative cs times Laplace transform of ft. So e to the negative cs times Laplace transform of what is our ft for this case? It is t minus pi minus 3. That's what you get, right? And minus e to the negative 4s, that's the formula, times Laplace transform of ft in that case. That is this function, right? That goes there. Okay, now you use the Laplace transform. So 5 over s plus e to the negative 2s is already there. Laplace transform of t is 1 over s square minus Laplace transform of pi minus negative pi plus 3, because if you take negative out, that will be pi plus 3. And then that has the Laplace transform. It is just a constant, right? So constant will be constant over s, because Laplace transform of 1 is 1 over s. So if there is Laplace transform of 5, you will write 5 over s. Okay. All right. So similarly, e to the negative 4s. Okay. Laplace transform of t is 1 over t square. Laplace transform of 4 minus pi is 4 minus pi over s. Now, how do I find out the Laplace transform of e to the t plus 4? Laplace transform of that. How do I write that? Since you can break this guy, you can break into e to the t times e to the 4, right? So you can pull that e to the 4 out and then find out Laplace transform of e to the t. You see that? So what is the Laplace transform of e to the t? It will be e to the 4 times 1 over s minus 1, right? 1 over s minus 1. That's what you get. So that's why you get e to the 4 times 1 over s minus 1 for the Laplace transform of e to the negative e to the t plus 4. The last thing we want to do on section 5.5 is we want to find out the Laplace transform of a periodic function. So first of all, what do you mean by a periodic function? Okay, that's the thing that we want to discuss first. And then we will talk about the finding the Laplace transform of the periodic function. Okay. So a function ft is said to be periodic with period t, which is positive number, if f of t plus t equals to ft, meaning that if you replace t by t plus uppercase t, then you will get the exactly same function. Okay, this means the graph remains unchanged if you shift left or right by t units. Okay, so and there is a note: if f and g are periodic, so are f plus g and f times g of the same period. Okay, so let us see an example. Sin t and cosine t are periodic with period 2 pi. So how does the graph of sin t look like? The graph of sin t look like this, right? So it is a period of 2 pi. So it is like, so this is 0 and this is pi. Okay, and this is basically 2 pi. So 0, pi, 2 pi. So if you shift 2 pi units, you will get exactly the same graph. So the graph does not change. That's what the periodic function means. Okay. Similarly, the tangent t is periodic with period pi. The function ft equals to t, where 0 is less or equals t is less than 1, has period 1. Because you see that if you shift it, you will shift 1 unit, you will get exactly the same function. Okay. This is between 0 and 1. And if you shift it, you will get exactly the same function there, same shape. Shift it again, shift it again. So exactly. So this is basically called a sawtooth function. So this is also a periodic function with period 1. Let's see another example. The function ft equals to 0 for between 1 and 2, and then 1 between 0 and 1. So this is a periodic function with period 2. This is called square wave function. Square wave function. So you see that between 0 and 1 it is 2, right? And between 1 and 2 it is 0. So if you shift it, that's what you will get. If you shift it right, that's what you will get. So basically this is called the square wave function, and this is also periodic of period 2, because you have to move 2 units away, right? And then again another 2 units away to get that exact same shape. Okay. There is a formula to find out the Laplace transform of a periodic function. What it says is, if ft is a periodic function with period t, then the Laplace transform of ft is 0 to t e to the negative st ft dt over 1 minus e to the negative t. That's the period. Uppercase t is the period, right? So let us do this example. How do I find out the Laplace transform of this periodic function? For the above square wave function, Laplace transform of ft is 0 to 2, because this is period 2, right? So that's why you write 0 to 2 here, e to the negative st times ft dt over 1 minus e to the negative t that t is 2, right? So 2s. Negative s times 2, that is negative 2s. Now what you do is this 0 to 2 has 0 between 1 and 2 and 1 between 0 and 1. So this part will be 0, right? So you just consider 0 to 1 only on the integral because the other part is 0. E to the negative st times 1 because ft is 1 in that piece, right? So that's what the 1 is, over whatever we had, and then you find out the integral of that, e to the negative st over negative s, and then the limit is 0 through 1, right? And you plug in the limit and you simplify, you'll get 1 over 1 plus e to the negative s. Okay, this is what you get. So these are the homework problems from section 5.5, question number 7, 8, 10, 11, 15 and 22. All right, guys.